Welcome back to another video of Dillard's Hacks. In this video, I'm gonna talking about FakeGrayscale. FakeGrayscale is a project maintained by me, only myself, attempting to convert a normal VFD display that's capable of brightness changing into a grayscaleable display. But first off, I'm gonna take a look at the VFD display itself. It's in the box. Did you see it? I'm gonna take a look here. Wow. It's in the box nicely with the data sheet sent straight from Stamford, UK in this package. And this display is in new condition, but I'm playing around with this for quite a while. And some of light. And it turns out as this project is failed on this particularly display because this microcontroller itself will be the middleman between the host, maybe the CPU or this microcontroller like an Arduino Uno, and communicating with the display. So middleman cause things to slow down. You can take a look at here, it's not focusing, but it's okay. So basically things gonna delay really much. I have the plan to fix this, but it's gonna be later because it requires entirely coding bit banking to the display itself, bypassing this little microcontroller here. But I have another display laying around. I have a lot of something I would call vintage display. I'm putting things in the back, and there are a lot of these. Oh. This one is a VQC10. It's made in Germany very long time ago, before it was born. Everything on this disc except this one. I'm talking about the display. The LED display I have mostly made in 1990s. This one, two of these, this one, and another one that in the box. But this VFD display is made in 2007. I'm gonna talking about this later. Maybe I'm using in another project because it's suitable for this plain text. I think maybe gonna make a CPU stated display, some sort of things that. So we're gonna take a look at the display that I'm focusing on these little tiny things. So let me keep things in the back. So I'll put the link down below about this VFD display. This is pretty cheap. I got for about £16 included shipping, but the display itself is about £6. So keep things in place. Oh, forgot to talk about this display a little bit. This is a Noritake e-tron VFD display. This is GU280X16G-7000. I'm gonna talking about this later, not in this video, because it failed. The project that I want to make is working. Maybe very soon and cooperating with my STM32F3 discovery board and make everything beautiful. So take a look at this. Can we get closer? This is what I'm talking about. Let's give some light. This is the LED display. They have 4 characters, and it's a 5x5 matrix. It's pretty weird. I accidentally found this online, but I can't find anywhere to buy some of these. But luckily, there's some shiny seller on eBay selling some sort of electronic parts, and I got this one for about $11. I will drop the link down below for the green LED version and the red one that I'm using. I actually want to get another one that's been green. Maybe later time, if this project success, I will get another one. So this is the take a focus. So let me read for you. This is STDV5542 made by Siemens in 1996, week 35, 35th, okay. So basically this is just a WFD display. Oops, sorry. This is just a LED display that using in electronic equipment, for example the frequency counter. But it's pretty weird that most of display will be like this, displaying in the horizontal, but this one is vertically. That's pretty weird. So let me compare to one of these. This one, yeah, this one I'm fighting for. This display is HDMS 2915. This made in 2007. 7th weeks 10. Sorry. So this one made in Malaysia. Not sure with this one. So most of display it have a 5x7 matrix. This one have 8 of digits. I also will put the link down below for this one. I got for $11, and 2 of these I got for free shipping. This one is from China. This one from somewhere I'm not really remember. So this is also capable of brightness level. Maybe later gonna make FakeGrayscale capable of this little tiny display. So most of display showing character text in horizontal orientation, but this one is in vertically, and it made me think about Japanese characters that will be displayed, because these are be able to put a bitmap. This one does not integrated with a ROM. It's just already a RAM, and it's actually RAM with a shift register. You just address any dot is a dot addressable display. It's like the WS2812 RGB LED display, but it's just using the SPI, or what you call it, SPI communication. I will not talk about this 14 digit display. Not this one too. Gonna keep on another videos. So I will focus only this display. So I'm gonna zoom in a bit. Okay, here we are. So this setup basically made for the ESP8266 ESP01S, and actually got this connector from a PC. I just cut them and solder the wire, use a tube string to protect them from shorting. And here we go. Let's take a look at this one. So I will try to powering up with a battery. So here we are. Make things secure. So I hope the camera cannot be capturing anything. This can be a little bit, but I'm gonna turn off the light. Okay, I barely see nothing. That's pretty weird. Sorry. It seems that the connection had a problem because I need to use my hand holding the battery and keep the lid touching the bottom of the battery. So maybe use something to help this. This is actually working pretty fine. The principle of fake grayscale is pretty easy. This display is capable of 7 level included, not included the 0 level brightness. So for example, I will display the 4 characters TLHX, and when I set the brightness to 100% when I set the brightness to 100%, all of dot that lit up is gonna be the same level. But if I display characters individually, we're switching between 1 2 3 4 1 2 3 4, and their own digits have their own brightness level. So like here, for example, like on the first digit I set for the brightness 100%, next one is 50%, next one is 22, next one is 0. It's gonna have a different brightness, but we can't combine them all at the same time. So I'm gonna use some technique that maybe using in the most of electronic things that equipped with screen in these days. Just basically is like a frame. So this display consists of 4 frames. We're not talking about multiplexing things because it's gonna be more complicated things. We're gonna talking about the fundamental part that can create fake grayscale. So it's like, for example, TLHX. So we have 4 characters. Each character they can have 4 individually characters, and that means you have individually frames. First character is the first frame, the second is the second, third, and fourth. So basically we just display individually and recycling through them very fast and trick our eyes. And this phenomenon called persistent of vision, or POV, which is, some of you may know the POV display that's using maybe in the fan is spinning very fast and have the LEDs, and it have some sort of animation or colors or things you can find in YouTube and search for the POV display. The persistence of vision make our eyes see the moving. It's not moving. See a multiple frame at the same. Basically, for this one is very small display. I will not talking about the size, but I will talking about the amount of dots on the display. So more dots need faster screen needs faster shift register or multiplexing things to scan across the display to get a very high refresh rate. So they have 5 by 5 dots, which is very easy to driving it. And basically controlling the brightness of this display is using pulse width modulation, or PWM, because it's cheaper than using something called digital to analog converter. For example, this is a FIO Q1. This is a DAC and headphone amplifier. DAC is converting the digital signal, a binary 1 and 0, into the analog voltage signal. So you might have heard about analog to digital converter. For example, Arduino be able to do that. You see the A0, A1, A2, 3, 4, 5. This one is an analog to digital converter. But if you're talking about DAC, I need to show you something. This also DAC, but this one is for it's an amplifier, headphone thing, blah blah blah. My dad gave me. So I have one of my controller that be able to output the voltage signal, analog signal, because it have that is STM32 F3 discovery board. I'm not really sure where it's gone. It's capable of that, but that is very expensive thing, and it's not be able to put into tiny things like this. Maybe if using a silicon chip, but the PWM is easier and it's not complex as the DAC, so it can be integrated into this little tiny LED display. The reason that I am using ESP8266 ESP01S because it have very small size and it's perfectly have the pins that are capable to be the output GPIO. So I use a TX, RX and a GPIO to be the output for the clock signal, data signal and the chip enable signal to the display itself. I want to demonstrate for you, but my camera does not capture things well, so maybe I'm gonna turn off the light and I'm gonna try again. Maybe I'm gonna using some of thing that can provide us voltage and very good and stable. And use this little tiny wires to hold the display in place. I don't need to hold this, so it's gonna be better. Oh, it's out of frame. It's out of frame again. I don't know where to put it directly things. So here we go. In the middle. Just the middle. In the middle. Already. Just bring the light away. So maybe we'll be able to capture. Okay. This is very dim. This is pretty dim. As you can see, it has different brightness. That's pretty cool. It's just done on this little display. Just zoom in a bit. I hope it's not lost focus. Oh, it's not focusing. Sorry. Hello. Hello there. So we're gonna turn off the light. As you can see, they have a differential of brightness. But trust me, bare eye seeing this thing better. So turn light back on. This is just a simple project, but it can help us a lot. The display is capable of brightness changing. Can basically cover whole thing. Can basically display grayscale bitmap. I'm working on the code right now. I actually have the library that can be displayed characters, scroll the text, but not with displaying the bitmap. I'm working on it right now. Maybe release, maybe gonna update within 2 or 3 days before ending my vacation. So this is just a simple project, but it can help us a lot. For example, I want to use this display to create some kind of wristwatch in the tiny, and the size is small as this rubber band. and just integrated some of small coin cell battery, maybe the one is smaller than the coin cell, and using a tiny microcontroller, for example this ESP8266. And I'm working on a project that using ESP8266 I'm doing about Internet of Things, aka IoT, gonna make things better, so it can have these tiny things in a wristband size, and just create a wristwatch and connect it to the phone to make things always on using a better battery, and connect it to the internet, so when the light have some sort of notification come from the Facebook, it's gonna show up on the display. So I will done this project pretty soon. Stay tuned, and thank you guys for watching this video. Don't forget to subscribe and like this video. Sorry for my bad English. I am still practice learning about to speaking the natural English better, but at least I can talk to foreigner better than before, improving myself. And see you again in next video. Sure.